In this video, we're going to go through Learning Target 2.3.5, which is on the characteristics of real-world graphs. So instead of just talking about those characteristics outside of a context, we're now going to put them inside of a context and work on that. So this is on page 15 in our packets, but if you don't have the packet, it would be helpful to pause the video now and make this chart in a notebook so that you have like a spot for slope, a spot for y-intercept, a spot for independent variable, and dependent. That'll be helpful. So every time we're given a real-world graph, the first thing that we should do every time is to read the graph's title and the labels. So like on each axis, the x-axis and the y-axis, read what those are so that you have some information about what's going on for the scenario. So once you've done that, we're going to ask you're going to have 4 questions you're going to need to answer. The first is, how is the slope interpreted in that meaning, or in that context? So what does the slope actually mean? So what you're going to do is you are going to first find slope using rise over run or the slope formula. You could really do either, but we're going to be given graphs, so that's probably easiest to just count rise over run. But if you like the slope formula or you feel more comfortable with it, you could use that as well. Then you are going to label, and our rise is our y-axis label, and our run is our x-axis label. So you want to figure out like what is the rise representing, and you do that using the labels or the titles. And then the run is the x-axis label. And our last step is always going to be to interpret. So you're going to have to like write a sentence for this. You can't just have a number or a label or anything. So then we are going to do the same thing but for the y-intercept. So the first thing we do is we find it out of context. So you find the y-intercept. And then what we do is our y-intercept we can interpret as a starting point. So once you find that value, then you figure out, well, what would be a starting point in this scenario, and how does that relate to the y-intercept? If you need to pause that to make sure you have those two down, please do so. Otherwise, let's talk about the variables. So this might be familiar with your biology class. So you do independent and dependent variables in your biology class as well. And those are usually in some sort of experiment. What is the independent and dependent variable? This is similar, but not always they're experiments. They can just be things that we're observing. And so independent variables we are going to define as the variable on the x-axis. So that is the independent one is whatever is on the x-axis. And you can also remember your biology definition. So you can remember that the independent variable causes the change in another one. So we can say it causes other variable to change. So then our dependent is the variable on the y-axis And also it is changing based on the other variable. So the only reason it's changing is because the other thing is happening. So again, if you need to pause this to get these both down, please do so. But let's go through an example. So we have this graph here, and the first thing that I want to do is I want to read the graph, all of the titles, every piece of information it gives me so I know what's happening. So this says gasoline usage. So that's what this graph is about. On the x-axis, it is labeled miles driven, and on the y-axis, it's labeled gallons in tank. So I can assume that we are driving some sort of vehicle that uses gas. And you can see that the gas is going down as we drive, which makes sense. So maybe we're in a car or a motorcycle or something, but we are using gas and as we drive. So now for the slope meaning, I first want to find the slope without a context. So I just want to straight up find the slope by counting rise over run. So I see that this is on a corner and this is on a corner. Be careful with real world graphs because sometimes their scales, they're not counting by 1 every time. So if I look here, 14 to 13, I go down 1. And then my run, I go over 1 box, but if I look, 25 to 50 is actually 25. So my slope is negative 1 over 25 without a context. My second step for slope meaning is to label. So my rise, I want to label with my y-axis. So negative 1 represents negative 1 gallons. And 25 represents my x-axis, which is miles driven. And so now I want to interpret that. This means I am losing, because it's negative, I'm losing 1 gallon for every 25 miles I drive. So we can say we lose 1 gallon every 25 miles driven. So find it out of a context, put some labels on there to help you, and then write it in a sentence. Be careful with if it's negative, you'll want to say something about losing or dropping. If it's positive, you want to say something about gaining in that word. So now similar with the y-intercept, let's find it out of a context first. And our y-intercept is where we cross the y-axis. So you can see right here is where I cross the y-axis, which is 15. And then I want to look at the y-axis, what that's labeled, that's gallons in tank. And so I want to interpret my y-intercept as a starting point. And so if I have 15 gallons, then I can say something like the vehicle had 15 gallons to start. So before we started driving, we had 15 gallons in our tank. So the y-intercept is always going to be some sort of starting point. This is how much money they had to begin with. This is how much gas they had to begin with, and so on. Now let's look at the independent and dependent variables. So independent variable is the variable on the x-axis, or also the one causing the change to happen. So on the x-axis, I see miles driven. And we can also think about it as if I'm driving miles, then I am losing gallons of gas. So if I don't drive anywhere, I'm not going to lose any gallons of gas. If I drive really far, I'm going to lose a lot. So the miles driven is causing the change to happen. So that's my independent variable. My dependent variable, the one that depends on the other, is the gallons in tank. So the gallons in the tank depend on how many miles we drive. That was my cat. She's basically saying we're done. So these are the notes. You can go ahead and flip to page 16 and work on the independent practice. If you feel like you could use another example or some more tips for this, please watch the extra help video.